Welcome to all to the Structural Analysis 1 lecture series by Nagashri B. In this lecture series, I am going to cover the core syllabus such as Introduction and Analysis of Plane Trusses, Deflection of Beams, Arches and Cable Structures, Influence Lines and Moving Loads, Analysis of Indeterminate Beams. Starting with the first concept of the Structural Analysis 1 lecture series, that is Introduction and Analysis of the Plane Trusses. Here, in this first concept, I'll be covering structure and structural forms, conditions of equilibrium, load transfer mechanism in a structural system, degrees of freedom, static and kinematic indeterminacies of structural system, difference between determinate and indeterminate structures, types of trusses and assumptions in its analysis, analysis of determinate trusses by method of joints and section methods. Now coming on to the definition of a structure. So what is a structure? Structure is an assembly of elements which are interconnected with each other and exposed to the external loading and transfers the same amount of load to the underlying system. So structure is nothing but it is an integration of the various elements which are interconnected with each other and are collectively exposed to the external loading, and the same amount of load is transferred to that of the final system, that is called as underlying system. So for example, I'll just consider a building. Okay, so in that building, let 5 kilonewton is a load acting on a building. So if the 5 kilonewton is the load acting on the roof of the building, okay, so that amount of load will be transferred to the first to the slab, and then to the beams, and then to columns, and then to the final, that is the footings, and it will be reaching to the earth, underlying earth. So here the starting element is the roof or the slab, and the final underlying element is the foundation. Okay, so structure is the one which is exposed to the external loading and transfers the same amount of load through its neighboring elements. Means, so from beam it transfers to columns, and from columns it transfers to the foundations. Okay, so it is called as a structure. So structural analysis is nothing but it is a study of determining or calculating or finding the impact of the structure of the loads acting on the structure and along with its neighboring components. So structural analysis is nothing but the study of determining the effects of the loads acting on the structure and along with its neighboring components is called as structural analysis. Now the next concept is nothing but structural forms. So what are the structural form? As I said in my earlier slide, the structure is the one wherein it is the integrated element in which it is interconnected with the small elements through which the load is transferred to the underlying system. So the small elements which compose the large structure is called as the structural forms. The elements of the structure through which the load is transferred to that of the underlying element is called as a structural form. Basically, the structural forms are divided into or classified into three categories. So first one is the one dimensional structural element. So here in this type of element, the load is applied only along the longitudinal axis or along the length, and the length of the member is very large compared to the width or depth of the structure. And as I said that the load is applied along the length itself, the bending will be taken place along the length itself. No doubt the bending will be taking place along all the three directions, but when we consider the effect of bending, the effect of bending will be more as in case of length compared to that of the other directions. Hence I just generalize that the bending takes place along the length itself. So typical example for this one dimensional structural form is the beams, cables, etc. So here I have represented through the figure. I just considered a simply supported beam through which the simply supported beam through which F is the amount of load which is acting along the length. So you can just see here the bending as well as the deformation or deflection will be taken place along the x direction itself. So the next type of the structural form, it is the two-dimensional structural form. So here in case of two-dimensional structural form, the loads are applied both along the length as well as width, and deformation will be taking place in both the axes, that is x and y directions, and the thickness of the element, the thickness of the two-dimensional structural form will be very small compared to that of other dimensions. So example for this is plate structures and shells. Next, I have taken a sketch of two-way slab. Here in this sketch, the dotted lines represent the initial position of the structural element before the application of the load, and the bended or the lines represents or the bended lines represents the deformed shape of the two-way slab due to the effect of the external load application. So here as I said that both along x and y axis the deformation will be applied, deformation will be expected. So here whenever I just consider the load applied along x direction as 6 kilonewton and along y direction as 7.5 kilonewton, so wherever no doubt there will be the deformations in both the directions, but when I come to the effect of the load, whenever the magnitude of the load is large, definitely in that direction, in that respective direction itself, you can expect more amount of deformation compared to the other dimension. Okay, so the next type of structural form is the three-dimensional structural element or three-dimensional structural form. Here the loads are applied along all the three dimensions and deformation will be in all the three respective directions, that is x, y and z. And for example is you can just take all the space structures can be taken as an example of three-dimensional structural form. Here I have just taken an example of a three-dimensional frame. Here in a three-dimensional frame, the load is applied along the length, width and the thickness. So the bending also will be applied in all the three respective directions. So I just give you an explanation what is a frame. Frame is nothing but It is a combination of beam along with a column is collectively called as frame. Thank you.